In Chapter 7, we're going to use what we learned about confidence intervals from Chapter 6 to explore a concept called hypothesis testing. But to do that, we're going to need some basic terminology. The first term that we're going to cover is the null hypothesis, which is designated by H sub 0. And that's just basically the default conclusion that you would draw if you didn't have any evidence to support another conclusion. The alternative hypothesis, or the research hypothesis, is written as H sub A for alternative, and it's the conclusion that requires evidence. So it's the conclusion that you would need to see some supporting evidence to draw that conclusion. And to determine if we're going to take the null hypothesis or the alternative hypothesis, we're going to use what's called a test statistic, and that's used just to decide if we're going to stay with H naught or take HA. And for our purposes, that's usually going to be the z statistic that we've been using for the past several chapters, which is our x bar value minus some mean, which we're going to be able to determine later, divided by the standard deviation for those x bar values. When we're dealing with hypothesis testing, we have two different types of error that we deal with, type 1 and type 2 error. Type 1 error, or alpha, is where we accept the alternative hypothesis when the default hypothesis is actually true. And then type 2 error, or beta, is the flip of that, where we accept the default hypothesis when the alternative hypothesis is actually true. And to be able to determine which conclusion we're drawing, we're using our rejection region, which is the region in which if the test statistics lies within that bound, it results in the rejection of H naught for favor of HA. So we're going to use that to be able to determine which conclusion we're going to draw, and based off of that drawn conclusion, we can have two different types of error, type 1 error and type 2 error. An easier way to think about the different types of error that we can have in a hypothesis test is with this basic table, where we have the true statement of nature, which is what is actually happening, along the top, and down the side we have the conclusion that we're drawing from our experiment. So if in actuality H naught is true and we accept H naught, then we have the correct decision, obviously. And the same holds for if HA is actually true and we accept HA, then we have the correct decision. But if instead we're accepting H naught when HA is in fact true, we have our type 2 error with the probability of beta. And if we accept HA when H naught is actually true, we have a type 1 error with the probability of alpha. The final piece that we're going to cover in this video is the elements of a hypothesis test. And those are broken up into two different sections. We have what we do before an experiment and what we do after the experiment. So before the experiment, we determine what our H naught is, what our default conclusion would be. We determine what HA would be, what our alternative conclusion would be, so what we're trying to see if we fit in that bound. We establish our test statistic, so most of the time that's going to be our z statistic. And we're going to calculate our rejection region, or the region where if our test statistic falls within that bound, we're going to accept HA as opposed to H naught. Then after the experiment, we're going to state our assumptions, what we assume about our data in our experiment. We're then going to calculate the values for our experiment and the values for our test statistic to determine which conclusion we're going to accept. And then finally, we're going to state that conclusion and say we either accept HA or fail to reject H naught.